Hello, everybody. Welcome to our installment of Showtime Goones. Today we talk to a good friend of ours.
Yeah, so Brian, our friend, who we know from our university days, he works at a nuclear power plant, and he's going to tell us all about what it's like to work there, how a nuclear power plant operates, the process of generating energy. He gets into some pretty good details, so for all of you people that like the details on the technical stuff, I think you'll like this episode. And where can they follow us, Berto?
At Facebook, Twitter, Instagram at Showtime Goones. Everybody, today we're going to talk to Brian. He works at a nuclear plant. So I have a few questions for him, and hopefully,
I guess we'll start with the first question. So Brian, I know, and Berto knows, but why don't you tell us a little bit about yourself, schooling, your degree, your career?
Yeah. So, like I said, I'm Brian Sarno. I work for Southern California Edison at the San Onofre Nuclear Generating Station. So actually I met Fernando at Cal Poly Pomona. So my background is mechanical engineering. Graduated in 2009. Worked for about a year outside of the power plant, and then in 2010, summer 2010, I joined Edison, and I've been there in different roles, all within engineering, mainly design engineering, and then going into some other parts of engineering. And then right now, I'm one of the few people left that are still there for the independent spent fuel storage installation.
So what is it like to work at a nuclear power plant?
I'll go back to when we were operating, because now it's a little bit different when we're shutting down. Like shut down, we're not producing power, but it was a lot of scheduling activities to plan for outages. So we're a dual unit. So if you drive by Camp Pendleton area, you'll see the two big domes on your way to San Diego or coming back to Orange County. And so they're on different cycles. One would do an outage, and then another one, a couple, like 6 months to a year later, would do another outage. So a lot of times it would be systems managing. You are just full out for those times during the outage for a month to a couple months or whatever it is, to getting everything implemented, all hands on deck to get the work done. So there was a lot of long days, and it was exciting. There was things that were going on, but I don't mind it slow down a little bit.
How big in workforce?
Yeah, so when we were operating, I think we had close to 2,500 employees that were within the company, and then we still had people that would work in there were so many different departments in maintenance and engineering. Engineering was made up of a couple hundred people at the time, and then you had the operations group was a large group, and then probably one of the largest groups on site was actually security. So after 9/11, there was a lot of changes that happened for security until we had shut down, and even when we had shut down, security was still probably one of our largest organizations on site.
What prompted that shutdown? Was that plan already coming due, or was it?
So it was in a planned shutdown. So in I guess it was 2010 timeframe, we started to replace our steam generators, which is one of the major components that transfers the heat from the we call it like the primary and secondary cycle. That's the one time that you can actually have a release of radioactive material to the environment is through a steam generator tube leak. So we had replaced our steam generators, and then about a year and a half into it, when we were doing an outage, one of our units actually had a steam generator tube leak, and we had to file a bunch of analysis and technical reports to, let's say, the Nuclear Regulatory Commission for approval to restart. And it was taking so long, and we got to the point where we weren't sure that we were going to be able to get approval to start up one of our units, that it turned into more of a financial decision. We really need to be operating with both units in order to really make it economically feasible to run that site. And so it was sort of like a technical problem that led to a economic decision.
Okay. I imagine a lot of locals are probably, maybe happy about that just because of the potential.
There's a group of people that are definitely sort of political activists when it comes to operating a nuclear power plant. So they sort of like, in a sense, some people would team up to us, but there's always the next thing that they want to jump on, I guess I would say.
Gotcha. And so I guess for a lot of people out there, can you kind of give us an idea, like, how dangerous are nuclear power plants?
Yeah, compared to, so my personal experience as far as to when it comes to industrial safety, I'd say we are by far well above safety-wise of any other, like a coal or a gas power plant. We have so many more regulations that we have to step through, procedures, training, and that sense. As far as the safety from a radiological standpoint, I think maybe there's a misconception that, a nuclear power plant, everything's radioactive. We have, if you drove by, that's our containment, and that's where the primary system is held. And then we also have some other sections that we call the radiologically controlled area. And so we have to go through a crazy amount of training. Well, say crazy amount. You go through training, and then we go through what we call practical factors that demonstrate we know how to employ the training. Plus there's an entire group, an organization actually on site that's radiation protection, where it's their job to keep track of everything that's going on, where the spots are, where we shouldn't go. So when it came to that, there was many hours put into planning to make sure that we would get as little to no radioactive exposure as possible.
And Brian, like, one of the things I've noticed is, why are these power plants or nuclear power plants always by like a lake or some ocean or some body of water?
Yeah. So it's pretty much just the whole, because it has to do with the heat cycle. So I guess for one part, we could say bodies of water, but you even have maybe you go by Palo Verde, which is just outside of Phoenix area, where they have large cooling towers. Your biggest thing is you need an ultimate heat sink for your system. And so large bodies of waters are really good in the sense that you have so much more mass volume to work with that you're able to use that to reject more energy to have a smaller impact on kind of temperature changes too. So the big part of the cycle is you want to go from really superheated steam down to condensed liquid as quickly as possible, because that helps draw a lot of the energy. So by having ocean be our ultimate heat sink and pumping.
Yeah. And who would have thought thermodynamics was going to play a big part in this, after.
Oh, yeah. Yeah, no, it's a whole, that was the fun part when we were looking at stuff, was just initial starting out. Every engineer, when we come on site, if you want to maintain as an engineer for the power plant, is you have to go through 4 weeks of introduction training. And so 1 week essentially is just the whole power cycle and understanding what's happening. So if operations is talking about everyone has an idea what's happening. But yeah, so it's all just very interesting for having reheaters, feed water reheaters, just to keep everything as efficient as possible. I guess this goes back to the question you're asking, which I sort of neglect to say, is at Cal Poly, thermodynamics, but we at Cal Poly had our own steam power, a small one. We only used a boiler, a gas boiler, and we had a couple stage turbine, but we had a reheater and everything. It was really cool to map everything out and really understand. We had a steam power class, and then we had a nuclear power class too. So I guess going back to the ultimate heat sink part is you really want to change that as fast as you can to get that turbine going and get as much energy out.
Well, what kind of environmental impacts does that have on that?
Yeah, so that's a good question. So if you were to go to San Onofre State Beach and look out towards the ocean, you'll notice two buoys. One is about a mile out, the other one's about a mile and a half. So we have our pretty much, I'll just call them conduits or intake structure. They're huge pipes. You could drive a bus through in like 18-foot diameter. And so what we do, instead of it just drawing in one area, if you were going to do that, yeah, you get huge heat changes in that area. But we have diffusers for our discharge to the ocean that it really only changes the temperature when we were operating a couple of degrees. So there wasn't really much from a temperature standpoint. And actually what happens, it's almost as though the marine life in that area treated that like its own little reef. So we had looked at when we were shutting down about potentially removing them, but there was a lot of environmental studies said that it would be more detrimental to the environment to remove them based off the life that's been added on over time. And then also something that we did, because there are some maybe sea life gets some fish we get into the intakes that we can't do much about, is we did a project of, we would have fish hatcheries to where and some other things, we built reefs off-site to help boost the environment in those areas too, to offset anything that we had done on the site.
Okay. One thing I've always wondered is, so how much energy do you get out of what is it, a fuel rod or versus?
Okay. Yeah, you know, we have these little trinkets essentially that we pass out. That's a nuclear fuel pellet. So a fuel pellet itself is kind of like the size of your thumbnail, essentially. And I gotta go pull up the conversions for it. I could probably run and pull that up, but it's I would have to pull out the exact numbers, but I have to get the ratios. It's a crazy amount of energy for what you have that comes out of that one fuel. And when you think about what we have in a fuel assembly, which is a grid of which has fuel rods, which is even more, there's thousands of fuel pellets in an assembly essentially, and then a reactor holds multiple assemblies. You have a lot of power in that one reactor. So I'll see if I can pull that up really fast, what the ratio was for it. I thought I had that pellet with me, and then I think I brought them all back to the office.
Yeah, no, I've always just been curious. You know, you have this system that generates X amount of power, and then you have a coal plant over here. I was wondering how much how much mass needs to go into that system in order to generate the same nuclear plant over here.
Yeah. And I apologize. Like I could probably pull it up, but I think it's hundreds of gallons of like oil essentially, or a couple thousand pounds one fuel pellet. So yeah, the amount of energy that comes out. And here's the other thing too, is our uranium dioxide fuel pellets, that's what they're made out of. They're not nearly as enriched as what you would have for like military grade. So like we're probably in the teens % wise for enrichment, which is like the amount of uranium for the percentage of the actual what's in the fuel pellet, where they're probably higher, like in the 80s or 90%. So that's why they never have to refuel. Essentially, they can stay out for forever. And then cool. We can, but there's a lot of different safety implications and transportation stuff with that.
Then aren't the next gen reactors supposed to be like way more efficient than the ones that we currently have? Yeah, so
I guess Westinghouse has their AP1000s. And when it comes to efficiency, is you kind of got to go back to the whole like power cycle, is how much energy you put in versus how much energy you get out. And you have like the Carnot cycle is the most efficient, and even if you have the most efficient, it's still like 35% or whatever. Well, if you looked at coal plants, just because there's so much technology, you're really only getting like 30% or like 32, 33. And there was so much technology put into that. So I don't know exactly where it's at, but I know you're getting roughly about 30% of the energy you put in is what you're actually able to get back out of the system.
Nice.
Yeah.
And so I guess so knowing that that the power plant that you worked at is in the process of being decommissioned. Mm-hmm. Can you tell us a little bit about what the process is like, how long it takes?
Yeah. So there's a couple different means and methods, I guess, for decommissioning depends on the so San Onofre is actually majority owned by Southern California Edison, but then there's still SDG&E, and then Riverside, and then Anaheim has it. So whenever someone was paying their utility bill to any of those companies, if there's a percentage of your monthly bill that went towards a decommissioning trust fund. And so while that power plant's operating, they're allowed to collect the money in the trust fund. So for us, we collected a couple $1 billion. So we were able to kind of like move forward with decommissioning. Some utilities didn't have as much in a trust fund. So what those utilities would do is they go into something called safe storage. So they would sometimes either move all their fuel out to dry storage, which is independent spent fuel storage, so it's not in the wet pools anymore. So you can turn off, and then you can just leave things there, and then wait till you develop enough money in your trust fund to demo the site. Or there's some people who just leave things in the fuel pool and leave it operating until ready. But for us, the biggest things is getting fuel out of the fuel pools into dry storage. And then that's really when you have your first part where it's like, okay, you can start going into demo stuff. I mean, there was a lot that went into before we got to that standpoint. But every single plant has to do a decommissioning cost estimate that they submit to get reviewed with the plans. So for us, it was a 20-year plan from when we announced to when we were actually going to be, what we would say, like decommissioned to return to essentially green state. So that's, you would drive by and you wouldn't see the domes anymore. The only thing that would be left would be transmission and distribution lines that you see cover. That's actually like a really large part of the grid that goes for California, and then the dry storage for the fuel.
Oh wow.
So
that's going to be a sad day when we drive by the 5 and they're no longer there.
You don't see the domes anymore.
Yeah, there'll be a generation of people who weren't even going to know it was there growing up.
So you'll be able to walk on the beach safely and everything afterwards?
Well, so I think that's another misconception people might have too, is that they think it's public land. So San Onofre State Beach, which is just there, that's a state beach. But the rest of that land is actually an easement with the Navy, because Camp Pendleton's there, and then you go farther down. So that's all naval land that the Navy eventually, when we give up the easement for certain parts, would go back to the Navy. So on the other side of the 5, which people might notice, and like unless you looked, when it's on the east side of the freeway, is we had a bunch of our engineering offices and warehouses were there. That's actually being turned over to the Navy again, because we didn't want to. We released the easement essentially.
Yeah.
So you'll still have San Onofre State Beach, but I think people aren't gonna, unless the Navy decides they're gonna change it to a beach. But I think they'd want to use it for training more than anything.
But how is the energy generated and how is it stored?
Yeah, so we use uranium versus like if you had a coal plant or if you had like a gas plant where you can have a boiler and everything. So what I was talking back to is the only difference between our power plant and it's just kind of like the fuel that we're using, I guess, and then we have a whole primary, secondary cycle that's dedicated to that. Is so we'll start with, you have your reactor, and then you have some reactor coolant pumps, and then you have the steam generators. That's the main part of the primary system, we'll say. So for nuclear power, since we already started operating, you leave every single fuel cycle. It'll take about half the fuel bundle out or a third of the fuel bundle out. I don't know if you've heard the term criticality, or like, hey, the reactor's gone critical. Sounds like it's a bad thing. That's actually what you aim for, is you want the reactor to go critical, because essentially it's like the same amount of neutrons you're putting in is the same amount of neutrons you're getting out. So a neutron hits a uranium atom, it then goes up, and then it turns into other atoms. You release more neutrons. That rate then activates other uranium, and then at that same part is you're releasing different radioactive isotopes. So you have your alpha, beta, gamma radiation can kind of go out too, and then but as part of it, the byproduct is heat. So essentially, all that is saying is like we're heating up water, and we pressurize that system to really high pressures because you don't want the primary system to have any air in it, because if you have air that gets into like a pump blade, you're just gonna destroy that. So there's actually a pressurizer that works off of heat too, to make sure that that system just is really, really hot water. We take that hot water to the steam generators, and then we have feed water that feeds on a secondary side. So you're just running hot waters through a tube like a radiator, and then you're just heating up the water that you do want to turn into steam. And the whole steam generator's purpose is turn water into steam and make it as dry as possible when it leaves. So then that way it can go to the turbine, and you'll turn a turbine, and then that turbine's connected to a rotor, which then can get the energy out to eventually, like through the transmission distribution lines, to the eventual consumer.
Cool. Yeah, that's really cool.
Yeah, so the only, I guess I'll go back to the difference and maybe why people think like with nuclear power is kind of like, I say we have way more energy from a nuclear power plant for the amount of mass energy compared to coal or gas. But the thing is, they turn their cycle off, they have an off switch or whatever, they're done producing heat. We go to shut down the cycle, that reaction's still going. There's still neutrons activating uranium. There's still fission cycles still going. The decay life for uranium is also so long, there's still energy being put out. So that's the part where, one, you have radioactive active material, and then two is that it stays hot for a long time. So that's why we have to keep things in pools till it cools down enough, which takes years before it can go into dry storage where it still remains warm, I should say, and it takes, the half-life is thousands of years.
Once you start that reaction, once you shoot the neutrons at the atom or electron, how do you control that? How do you stop that at the end of the cycle?
So there's a couple ways we control reactivity. The biggest thing is we use boron as a moderator, water itself as a moderator. But if to start the big, hey, we're going to come up in power, is so there's control rods. It'll be like a generic term people might understand, which has the ability to absorb the neutrons in a sense. So that's the way you can hey, we're going to come up on power. It's kind of like there's a lot of parts that go into it, but parts of heat drives power. You want to get it cold or you can get spikes. But I'd just say the biggest part maybe that people would understand is, okay, you want to remove the control rods, or so that way you can then let power start to come up. And if you want to cut the power, essentially you would want to drive the control rods in. So Fran, you were mentioning earlier before the call about the whole Chernobyl experience, and how they completely removed their control rods, so that way it wasn't really controlled. But when they went to go put them in, it caused a ginormous spike, which actually caused the explosion. So that's a bad design in the sense that you to fully remove control rods. So if you went into our control room, and we noticed if the system itself didn't shut itself off, and we knew we needed to shut down for whatever reason, the best way to shut it down is take your time, go slow. There's procedures to follow, and then you get the system slowly shut down. But if there was ever an emergency, there's some buttons you can push, and it'll kill the whole reactor. So actually, I'll say so you're in San Diego. I don't know. I don't think you were there at the time when it happened. This is before we shut down. Obviously, there was someone all the way in Arizona who's working on a transformer in one of the hottest days towards the end of summer, beginning of maybe it was October. Still a really hot day. But they just wanted to get that thing done. They tripped. The transformer blew, and it was drawing so much power that it was going to start overspinning our turbines, and so the system shut itself down. That was kind of an idea of hey, this is a quick shutdown.
Oh, cool.
Because that overspins and then it creates a lot of problems. So yeah.
Nice.
If it was a normal outage, we wouldn't be just saying, hey, let's stop it right there. It would go quick coast down, or slow coast down.
So Brian, from kind of like an odd question, but if you were to rate your knowledge on nuclear power generation from 1 to 10, 10 being like a genius and the most knowledgeable in the subject, what would you rank yourself?
Oh geez, it's like a loaded question, because there's always gonna be someone to be like, no. Yeah. I mean, I'd probably say like 6 or 7. Like when it comes to, I mean, for all the different parts, if I took those classes again on the reactivity control, but as far as it comes, chart of the nuclides and knowing all the different things that happen in the cycle and stuff, I mean, I don't know off the top of my head, but I could look into it and be able to explain it to somebody.
That's cool. That's really awesome.
So tell us about the San Onofre Power Plan and why is it so special, or what is so special about it?
Yeah, well, other than I've been working there, I just like it's my own personal connection. I love it there. Yeah. So, I mean, it's just I guess it's I'll start with the special part. It's like just the people you work with there, and this goes for the entire nuclear industry in general. Is that we're pretty much like team players and everything. There's no silos in the sense that like we try to shut other organizations out. If I ask for help, they're like, no, we're not going to help you, kind of thing. Everyone's there like a big family in a sense. If you guys go to any like the aerospace meetings, like we have ASME meetings, there's EPRI, which is Electric Power Research Institute. There's a lot of people in the community that get together on a quarterly basis, and I think that's what makes nuclear special for as an employee there, is that just the everyone's there to help each other out, because if something happens somewhere else, there's going to be the first question from the regulators, like, how come your site's not impacted by that too? So there's a lot of making sure we're all able to help each other out. So, but working at San Onofre, I mean, when I first started out, it's a great location. San Clemente is a nice place to be around. It was, I think, from a professional standpoint, is everyone knew you get your job done, you work hard to get it done, but then you could still afterwards go in a drink with your coworkers and have a good time.
Well, one of the cool things I remember a couple years back, so I followed you on Strava, and I guess I presume during your lunchtime you go for a walk. And you can just see like the map. Yeah. It's just, you're just pretty much like walking the coast, It's
I wish I had a picture for that too, but I mean, it would be that'd be like a half an hour you left. It's our parking lot so far from our offices, where like it's at least like a quarter mile to half a mile depending on where you park just to get to your office. So yeah, we had there's the bluffs there that would, and then essentially you just walk from your office to the entrance to San Onofre State Beach and back. So those nice lunch walks. Now where my office is, I'm pretty much like right there. I don't have an ocean view anymore, but I could just take a quick step outside and I'm right there.
Yeah.
That's very nice. So kind of going back to you were saying right now, the nuclear industry is very close. Do you guys share any data with other countries, or any not data but any
well secret? So EPRI has international members, which is an interesting thing, that so they'll gain access to a lot of the information, and then they can bring it back there, and they have different regulations. So if they decide whether they're going to follow some stuff that we have set up, but at least they have access to it. The Nuclear Regulatory Commission, kind of like they have their own branches other places, so they can sort of come back in. But yeah, so internationally, even so EPRI, Korea has a big nuclear program. So KPMG will bring people in. We have someone on our own site. It sounds weird that say it, but like you think from a nuclear standpoint, but fire protection is one of the other more difficult tasks for a nuclear power plant too. So we have like probably one of the leading guys in the world works at our site, so he gets kind of asked to speak to other people as well. But yeah, so they all kind of work together. They can come out. I know we get a lot of people from Europe that were coming over for those conferences as well.
And so switching the subject a little bit, one of the things that we've always thought about it, and I guess is working at a power plant or nuclear power plant, just like the movies.
The movies? I'm trying to think of what movies had nuclear power plants in them. I know TV shows like
or
people
TV
think
shows
like
too,
Simpsons.
Yeah. I mean, I'm thinking like, just like in my imagination, you're wearing like a white coat and a helmet, and you have a clipboard.
So if the general, like walking around, whenever on site, we have personal protective equipment. I have to wear a hard hat. I have gloves that are on me, or hearing protection if I need it. And then I have the clipboard for my own notes, just because it's easier to carry stuff around. I have the clipboard. I guess I could look like a little nerdy walking around when I'm like the engineer, and then there's guys carrying around heavy equipment. I'm just like, good job, guys, keep going. But yeah, when you go into the radiologically controlled area, depending on where you go, I'll say this then, like Monsters Incorporated, like Monsters Inc. If you have kids, or you like our own generation. I mean, I love that movie where you're like 2619 and then you see all the guys like pull up in yellow suits. I wouldn't say like we have full respirators, but where we go, you definitely have to, we call it dress out, a banana suit, in the sense where you're wearing a whole yellow suit. But that's not really to protect you from getting a radiological dose. It's more to protect you from getting contamination. So just like loose particles that like a piping, if you touch piping, it helps prevent the spread. So when we're leaving that area, we'll take off those coveralls essentially, and then they get processed. So that way when I leave, I'm not taking anything with me. It's all staying there. And then also as we're leaving, there's a couple checkpoints that they'll check to make sure we frisk our own hands, our feet, to make sure there's no loose particles. And then we walk into, they call it beta booths, where they'll check for different types of radiation, essentially. One thing that we always had is like, we'll get different gases that like to stick to your hard hat. Or people wouldn't think, and they're like, oh yeah, I thought polyester. Those gases like to stick to it, and then you get to hang out for a really long time, or they'll give you they'll take your clothes away. Then you
burn them.
cotton clothes to wear back to the office.
Do you need to get like a health checkup every year, or a couple of months or something?
Just like for a normal physical we're talking about?
No, just for potential exposure.
No, we before you leave the site, and then also when you're still coming through, they'll do something called a whole body count, and you're essentially standing in something for about like 30 seconds to a minute that's going to check you to see if you're carrying any type of radioactive isotope or anything's active in you. But other than that, it's not like, hey, so I think going back to your question too, for maybe if we reach certain exposure limits, like, hey, how do you know too much radiation, you're gonna grow like a tumor, or like that's always someone's concern, like you're gonna get like your blood's gonna break down, or you can get something else that's going on. There's federal limits, and then we have our own self-imposed limits, which is usually about half the value of the federal limits. So we're really, that entire organization I was talking about before about radiation protection is, every time I'm going in there, every single millirem, thousandth of a rem, is being counted, and I'm allowed to collect a certain amount, and then it's my responsibility to go in, and it keeps tracking the system. And if I'm reaching that goal, then it's kind of like, okay, you're not going in. There's some maintenance workers, I'll say, for help with outages, that's like kind of or even radiation protect. There's a whole bunch of different groups that want to jump around. Is they'll work at one site and then they'll jump to the other site, so they have to keep their record, because that's a federal requirement too. There's a lot of studies that instill those values to ensure that no one's really going to get any bad effects from any type of exposure. I would say if there was an accident, in the sense that someone got exposed or somehow something happened, then maybe that individual would have to get through some other examinations. But it's not a common practice, because we do a really big, diligent effort to ensure that no one goes even close to their dose limits is what we call it.
And so you mentioned Homer Simpson, and so
you ever say nuclear instead of nuclear?
It's pronounced nuclear.
Nucular. So with Homer, right? How likely is it for somebody with his level of education and intelligence to work in a control room in a nuclear power plant?
Does Homer have a level of education?
I don't know. That's
No,
I presume he doesn't, right?
Yeah. No, definitely not in the control room. Unless he somehow accidentally got clearance and just walked his way in there, which wouldn't happen because our security is so tight, like they wouldn't get through. But no, so I guess like, is it Lenny and Carl? Are those the two guys? So Lenny and Carl would probably be more from like, you think standpoint wise of have themselves put together, or like they know like, oh my gosh, don't do that. But the whole like, hey, there's like leaky stuff everywhere. That's not. And but so the people who are in the control room who are licensed operators, I talk about how I just have 4 weeks of training just to stay as an engineer. Become a licensed operator, the amount of it's crazy. You don't even work in the control room, and that's only a certain amount of people are actually in the control room. A lot of operators are actually like plant operators that are walking down pipes or walking down the valves, checking valve positions, checking pressure gauges, checking everything. Like, and that's just the mechanical side. Then there's a whole electrical side too. So a lot of them have gone through even being, they were in the nuclear Navy before, and they didn't want to stay in the Navy and they left. So a lot of those guys have and girls have a lot of training. But then even the control room operators, you have the shift manager who oversees all the operators. Then you have your shift technical advisor, who is kind of like an engineering role in there. They're all highly educated and they're trained. And then a big part with the nuclear stuff is there's a lot of continuing training. So when we were operating it would be 4 weeks that you could rotate on. So they retrain you. There's new things, like new systems that are being updated and everything. You get your training. That's a big part with, I don't know if it's the same for other engineering. I mean, I worked in HVAC for a while. I never really got trained unless I went to a conference or just something I want to do. We had quarterly training requirements just for engineering, and then you have annual training, and it's continuing training. You just work training into your schedule.
Mm-hmm. Cool. That's a good thing. That's definitely a good thing. I'm pretty sure, and I'm 100% sure that you don't get superpowers or you don't glow in the dark if you get exposed to
no
bummer.
No superpowers. Not that I'm aware of. I tried. That was the first thing I did with the wall. Didn't work very well. Yeah. I bring spiders to work all the time and nothing happens so far.
What's the lifespan of a nuclear power plant from the time we start, from the time they build it? How long does that take? How long is it active for?
So I'll just go back to kind of like where we were at too, was so when you apply for your initial license, going back, it's like a 30-year initial licensing period. So then whenever you get that license approved, depending on when you build it, could be 5 to 10 years, depending on how the project's going. I'll just say if you operate to your license, then you're at 30 years. Some sites have decided, you know what, when my license, that time has ended, we're gonna go start decommissioning. And then I believe I gotta go back and look at the federal amount of time I think the amount of time before you have to decommission is a very long time. It's like, we say 20 years is sort of like aggressive in the sense that a lot of sites aren't trying to aim for 20 years. So that's just the decommissioning on the back end. Then as your license is coming towards its end period, you can file for an extension for 20 years. And so some sites have done that, and they get another 20 years. So you just add it on. So it could be over 100 years of from when you start to when it's all gone, essentially.
You're talking different generations.
Yeah, and it's not, so a lot of those components too aren't necessarily like designed last that long too. So you look at the design life of a large component. Usually your reactors and everything are okay, but the steam generators are one portion. A lot of components were being changed, like your steam generator, your turbines can get replaced, the blades are being replaced because there's pitting forming from any liquid that can eat into it. There's a lot of changes that are happening that help support that license extension too. So it's not as though, hey, yeah, we started with what we had and we're just finishing it like driving a car 400,000 miles. You're really replacing a lot of major components along the way.
You know, we always like to ask our guests this question: is knowing what you know now, what would you suggest to somebody who's interested in a career in the, like working in a nuclear power plant? Like,
yeah,
what should they study? You know, like how should
yeah.
they
So
proceed?
that's and I was reading that question before too, and so I think that's part of it too. Is kind of like people think, yeah, I go back to before nuclear power plant. They think nuclear is very specialized, but I mean, you go to school for electrical engineering. Our systems, the whole purpose is to generate electricity, but everything that's there to help generate the electricity needs power to run too. So electrical engineering is a big thing. I'm a mechanical engineer that I really like thermodynamics, and I like that was my bread and butter, and I went through to that, but it doesn't necessarily, there's different parts. Or you can be a fuels engineer. I mean, that's just for, you could be a tradesperson too. There's so many, there's a large gambit. And then you think about that too, is we have a huge communications team. There's any other company you can think of that there's a position that you could find to work at a nuclear power plant to do it. As far as recommending someone if they want to get into nuclear power, just where we are now, just with the price of just say gas is so cheap now that it's starting to drive nuclear out. There's not really a lot of more sites are determining, the utilities are saying it's cheaper for us to produce gas power than it is to produce nuclear power. So I'm sort of hesitant to say, oh yeah, like you might have passed the bread and butter of like a good time to go. But I mean, if you don't mind going out of country, you want to do nuclear, you go to Abu Dhabi or you go to Emirates, and they're building a whole bunch of new stuff over there. They're paying good money for people to work there. Nuclear Navy, if you ever want to do that, I would say there was, for the longest time, you could walk around the halls, or even in operations, you can say, like, who was a veteran here? I'd say over half the people had all served in one branch of the military, mostly Navy. Or like you talk to security, a lot of them are former Marines. So there's a lot of options. Personally, I thought, I mean, you both went to Cal Poly Pomona, so just, I sort of was lucky enough, I guess, in the sense that I knew at an early age kind of, I wanted to get into mechanical engineering. I knew Cal Poly Pomona was a school I really wanted to go to. So if that's really like more like hands-on stuff, I would suggest one of those. Like Cal Poly Pomona to me is a great school to go to.
So with San Onofre being decommissioned, are you planning to see that through, or are you gonna try to go somewhere else?
So like as mentioned before, we had a couple hundred engineers while we're operating, and I've kind of been able to ride the wave in a sense. So where one of the engineers that's responsible of the few remaining for the independent spent fuel, essentially managing the fuel that's on site still, looking at inspections, just making sure everything's safe. We don't have a spot to send the fuel to, so my hopes are to stay with the company until as long as I can to be there to help with the fuel.
So Brian, this concludes the interview part of the segment of our podcast, and so the next part is we like to take the theme of the day and tell our guests jokes, puns, pickup lines related to the theme. So So we'll get you give us a thumbs up, thumbs down. First
Well,
one.
can I start with one that I heard?
Yeah, go ahead. We'll give you.
Yeah. So, okay. So this was like one of our first like engineering managers for the site. Essentially, we were just joking around. How do you tell the difference between an introverted engineer and an extroverted engineer? So
one
the
talks.
introvert. Sorry, one talks. No. So
yeah.
the introverted engineer looks down at their own shoes. The extroverted engineer looks at the other one's shoes.
That's pretty good. Oh gosh, that's a 2 thumbs up for me.
Okay.
Yeah.
And you guys can use that now, right, at work?
Yeah, definitely gonna use that one.
Okay.
So why did the nuclear power plant have an aquarium built next to it?
I have no idea.
To put all the nuclear fish and fishing.
Oh, wow.
And then, yeah, I think.
I don't know. I probably have to do it.
Yeah.
It's a good one. It's funny, but I get a definite lot of head shakes at work.
Yeah, for sure. So next time you're in the office and you have a headache, just say, "I have a nuclear headache. It's splitting."
Wow. Oh my gosh. Where'd you guys pull this material?
Hey, that's confidential information.
Oh, okay.
We can't give our secrets out.
Yeah.
Oh, okay.
Have you seen nuclear fallout before? It's rad.
Whoa.
I really love the way nuclear fusion works in the sun. Let's just say it brightens up my day.
I could probably get with that one. That's probably a little better.
All right, and last but not least, what do you call a nuclear physics plan for the future? A visionary.
We also like to give out some ideas on pickup lines. So let's say, hypothetically speaking, you're at some sort of nuclear power plant convention, or you just see, you're at the nuclear power plant and you see a cute girl, and you want to use one of these pickup lines. You're more than welcome to use any of these.
Here. Okay. So this was probably, I wonder if I can hold it up. But is this one that you would use? Is it backwards?
No, you made it.
Yeah, I definitely would use that one. Yeah.
Okay, that one you would use? Okay. Cool.
Yeah, 2 thumbs up for that one.
2 thumbs up? Okay.
Yeah.
Okay.
So the first one is, so like I said, if you're at a convention or you just happen to really like a girl that's
on the boardwalk or something.
Yeah, and you happen to like a girl that's really into the whole nuclear power
into the nuclear power
thing, you can say like, "Girl, are you the nuclear apocalypse?" And then she'll say, "Why?" And then you say, "Because I fall out for you." Yeah.
Or if that one
they'd probably give me a smile.
Yeah, smile probably.
Or you could just follow up with real quick and say, "Girl, I must be a nuclear reactor because I need you." I like that one. That's good.
Yeah, and then this other one here, it's really good. I like it. Girl, you're so hot, you would make a nuclear reactor meltdown.
The next one. Damn, are you nuclear fission? Because you got my reactor going.
Yeah. Okay.
Yeah.
That one's pretty funny. I don't know if I'd say those at conferences as much as like actually at work.
Yeah.
I feel like if I said it as a conference and then I'd just be like blacklisted forever. Like,
yeah, you'd be that
maybe,
creepy guy. You'd be that creepy guy at the conference.
Maybe like the girls that are walking next to the beach over at the plant.
yeah.
So Berto, funny story. Back in college, Brian and I used to joke around a lot in between classes. And
What, you joke?
yeah, of course. And one of the pickup lines, I don't know who brought this pickup line up, but it was like a McDonald's pickup line, and it was like, you tell a girl like, "Hey girl, you must be McDonald's," and then she says, "Why?" And is it because my face is greasy? Is it because And then you're like, no, because I'm loving it, right? But yeah, like there's so many ways that girls can take like puns.
Take it the wrong way.
Yeah, or like pick up lines the wrong way, and like, what are you saying? Are you saying I'm fat? Are you saying?
That's half the fun, man.
Yeah.
Yep.
Yeah. So I guess as we conclude this segment of our podcast, which hasn't been very successful, to be honest.
Yeah, we keep saying we're going to stop doing it. And here we are.
I guess we'd like to say that for everybody out there, make sure that you hit the like button, the notification bell, what else is there? Oh, follow us, subscribe to our channel. Yeah,
we're on Instagram, Facebook, Twitter. I forget where we're at.
Yeah.
Are you on Spotify?
No,
we haven't made that deal yet. No.
We haven't. Yeah.
Oh, okay.
At Showtime Goones, right? At Showtime Goones, that's our handle.
Yes, sir.
Oh, okay.
At Showtime Goones. Brian, thank you.
Thank you, Brian.
Thanks,
and then
guys.
for everybody, if you ever, when we release this, if you have any questions, you can write them down in the comments, and then maybe Brian will be nice enough to reply back.
Yeah. No,
Only nice comments, because
only good questions.
Only good questions.
Or if you have more nuclear pickup lines, I could pass along to others.
Yeah, for sure. So, like we always end every podcast with the saying is, for everybody out there, if you're not with us, you're against us, and we're perfectly okay with that. So until next time.